Hello guys, today we're covering we're beginning unit 6, which is over exponent rules, and we're starting with adding, subtracting, and multiplying monomials, which is a one term. We'll define that in just a second. And the big gist of this is the product rule for exponents. Here we go. So a monomial is a number or a variable or a product, which means multiplication, of a number and variables. Examples of this could be 5x is a monomial, 3x squared is a monomial, 9x squared y to the 7th, that's all multiplication between the number, the variable scenario, and the next variable scenario. Negative 5/2 x y to the 4th, that's all multiplication between each factor. Negative 6/11 or just 2. Those are all monomials. Okay. Monomials with the same variables and exponents are like terms, which we have already talked about and dealt with some this year. So this adding and subtracting monomials, we'll just be adding in where you have scenarios that look like this. We've dealt with some like this, definitely many like this. So to add or subtract monomials, you combine like terms. You do not change the variables and exponents. The only thing that changes is the coefficient. Only change coefficient, which is the number in front. Okay, here we go. So let's work some examples now. I'm going to jump to number 4. I'm going to try and work these as quickly as possible so the video is not as long, but that it still has enough explanation that's needed. Okay, when I look at this, I'm only looking to see, are the variable scenarios the same? Yes, it's x squared y, x squared y. Now I'm looking at the coefficients. Well, this is 38. This one here is understood to be a 1. So I'm technically doing 38 minus 1, which then gives me the answer of 37 x squared y. That is my final answer. Next, we're going to go to number 5. Okay, well, when I look at number 5, I first look at the variable scenario. This is AB. This is AC. Well, wait a minute. They don't have the same variable term scenario. These are different. So therefore, I cannot add them together. So my answer is 2AB plus 9AC. I just rewrite it as the answer because I cannot combine them together. Okay. Next, number 7. Okay, look, check this variable. Yep, they're the same. They're both CD squared. So that means I am dealing with the fraction section. Okay, well, I'm going to be subtracting these two, but I have to have a common denominator. So my new denominator needs to be 15. Okay, you can oops. So I'm going to have CD squared minus something over 15 CD squared. So 5 goes into 15, so I'm multiplying times 3. So this is 6. So it's times 5. So this is 5. So we end up with 6 minus 5, which is going to give me 1/15 CD squared as my answer. Next, we're going to jump to number 12. Now here I've got more than just two terms. So I'm looking at all of them, and I'm going to see that 10m squared n goes with the negative m squared n, which, remember, that's understood to have a 1. This one is completely separate and different. So I'm just going to combine these two. So 10 minus 1 is 9. So I have 9m squared n plus 7mn squared. This is my final answer. Last one for this page. Remember, you can pause and re-listen or come ask questions if you need to, or put a question mark by it because you watch this at night, to come and ask me the next day. Okay, now these are with some words in there. Sum is addition, difference is subtraction. This one is the one where it can confuse you. It says to subtract from. So I'm subtracting 9a from the negative 15a. So therefore, it's going to be minus 9a from something, which is the negative 15a. And now I'm just subtracting the coefficients because the variable scenario is the same, and we end up with negative 24a. I chose this one because of this scenario right here can be confusing. All right, next page with a little bit new information here. That kind of was very similar. This is the newer information. Okay. When we're looking at this, we're multiplying monomials now. We were adding and subtracting. So the product rule is when it has the same base, which is the x, then I add the exponents, only if it has the same base. Okay, so if same base, add the exponents. All right, so let's see, what does that mean and why would it work? So let's look at why it might work to begin with. All right, so if I have x squared times x to the third, that x squared means it's x times x. And then it's times x to the third, which is x times x times x. Well, when I put all that together, I end up with x to the fifth. Well, the rule is saying I can just work this by saying x to the 2 plus 3, which gives me the x to the fifth. Now, if you need to write it out in what I call expanded form until you learn and understand this, go for it. There's nothing wrong with doing that because it is establishing your understanding of why this rule works. So for 18, the reason I'm doing this one is because there is no exponent written here. It is understood to be a 1. So there's understood to be a 1 written there. So therefore, this would be a to the 9 plus 1, which gives me a to the 10 as my final answer. Okay, moving right along. And we're going to apply this rule to different scenarios where there are coefficients included. So with this, you multiply the coefficients and you simplify. That means you would add together the variables by the product rule. All right, here we go. So we're going to jump down and we're going to look at 24. I'll leave this right here so you can see it still. So I'm going to multiply the coefficients. So that means I'm doing negative 7. I'm going to write this out for this one so you can see what I'm doing. Negative 7 times negative 4. I'm kind of rearranging the order of everything, but it's all multiplication. So by the commutative property, I can do this. Then I'm going to have P, because now I'm looking at the P's. So that's a 9 and a 2. So I'm going to have P to the 9 plus 2. And then I'm going to have Q to the 3 plus 6. And then I'm going to have R, remember that's a 1 right there, to the, oops, got to write the correct thing, Kimberly, R to the 1 plus 4. So now my final answer is going to be a positive 28, P to the 11th, Q to the 9th, R to the 5th. This is my final answer. Okay, let's work another one, because sometimes these things can get a little confusing. With several steps. So let's look at 27. Oh, I lost you. So give me just a second. Trying to make sure I can see y'all so I can see what I'm doing. Okay, here we go. So when I'm looking at this, if I've got 3 terms, I need to understand, remember that the coefficient here is a 1. This is a negative 1. So I can mentally think, oh, well, that right there. Okay, so that's going to be 1 times negative 1 times 6 times A to the 1 plus 5 plus 1, and to the B 1 plus 1 plus 1, because I'm looking at all the coefficients. So this is a 1 times negative 1, that's negative 1 times 6. So that's going to give me negative 6. A to the 1 plus 5 is 6. 6 plus 1 is 7. B to the 1 plus 1 is 2 plus 1 is 3. So I have B to the 3rd. There's my final answer. Okay, 2 more, guys. Okay, looking at 33, where we pull in some of these fractions scenarios. So we're exposed to what we have to do. For 33, again, we do 12 times 2/3 times X. You always want it in alphabetical order, the variables. And then we have Y to the 1 plus 4. So 12 times 2/3, well, that's 12 over 1. I can cancel this, and that's going to become a 4, because 12 divided by 3 is 4. So 4 times 2 gives me 8. Then we have X. There's nothing to combine that with. And then we have Y to the 5th. So my final answer is 8XY to the 5th. Last one is 38, where we're combining the multiplying and adding, subtracting together. Okay, so we're going to do this one, the multiplication first, because according to order of operations, that's what we have to do. So I'm going to have negative 5 times negative 3 times C to the 1 plus 4 times D to the 1 plus 1 minus 7 times 2 times C to the 2 plus 3 times D squared. Okay, so that was, ooh, my papers are sliding down. They're not staying up. Let me see if I can find a way to make them stay. I'm going to hold it, yes. Okay. Next color, now we simplify. So I'm doing the negative 5 times negative 3. So that's going to give me negative 15 C to the 5th D squared minus 7 times 2 is 14 C to the 5th D squared. And I should be noticing right now that I have a common variable scenario here. These are the same. So I'm going to have negative 15 minus 14. Oh, that's not a negative 15. That should be a positive. Pay attention to your integer signs, Miss Wilson. And we end up with 1C to the 5th D squared, which can be written, and you'll probably just see it written as C to the 5th D squared as the final answer. I would accept either one of those as the answer. Okay, remember, if you have questions or need to refresh, Just pause it, re-listen to it, and be prepared to ask me questions when you see me. Have a great day.